Hello everyone, we are final year students of Electronics Engineering of Alchan College of Engineering, Sangli. Myself Sushant Patil.
I am Nikhil Magdum.
I am Aman Madar and we are going to demonstrate our project Smart Public Transport System with Bus Arrival Departure Timing with Vacancy Indication.
As world has moved on, so has technology. So today's scenario calls for a reliable public transit. Take example of a passenger who is completely unknown of real waiting time and vacancy of a particular bus. So ours is an attempt to blend machine-to-machine communication and transportation in order to achieve smart and reliable public transport. So the main objective of our project is to establish and to create a system which displays vacancy and arrival timing of a particular bus through medias like display units and webboard.
The system makes use of two wireless communication technologies, Zigbee communication for short distance communication between bus and bus stop, and a GSM communication for long distance communication between bus stop and the central server. Each ticketing machine has a Zigbee module connected to it, and each bus stop has two modules, that is a Zigbee module and a GSM module connected to it. When bus starts its journey, a bus reporting is done. That is, information related to bus ID and the route ID is given to the particular ticketing machine. When bus travels on its path and it reaches to the first bus stop, the bus will communicate with the bus stop. The bus will send valid information to the bus stop using Zigbee communication. The information consists of bus ID, vacancy, and the same information is forwarded to the centralized server by the bus stop by adding the stop ID into the information. Once the centralized server accepts the request packet from the stop, the server will process that packet, and after processing, the server will update the corresponding stops on that route by sending a message. So the next stops which are on the same path are updated with the new value of the arrival timing and vacancy of the bus. So a passenger waiting at the bus stop will get the updated value of the bus arrival timing and the vacancy. The same process repeats when next time bus reaches to the next bus stop, and the whole process continues. Now let's see the part with system demonstration, starting with the component description followed by the demonstration. Architecture. For the sake of easy understanding, the whole system is divided into four parts. We will start with the first part. The Zigbee module, as mentioned earlier, is placed with the ticketing machine into the bus. So ticketing machine placed into the bus is represented by this first part. Let's say a bus is traveling on a route where there are two stops in the first stage, that is stop 1 and stop 2. So stop 1 is alternatively called as current stop, and stop 2 is alternatively called as next stop. All the stops will contact with a central server which is placed at the bus stand. So this is the overall architecture. Now we will see the details of each of the part. A ticketing machine is formed by using 8051 family variant P89V51RD2. As seen here, the ticketing machine has 16:2 character LCD and a keypad interface. Ticketing machine will be inside the bus. A ticketing machine is connected to Zigbee module. This Zigbee module can communicate with the Zigbee module present at the bus stop. Whenever bus comes at the bus stop, interrupt can be used to transfer the information from the ticketing machine inside the bus to the bus stop. Stop 1 architecture. Stop 1 uses LPC2148. It has an ARM architecture. LPC2148 has two serial ports. One of the serial port is connected to Zigbee module to communicate with the Zigbee module present inside the bus, that is with ticketing machine. Another serial port is used to communicate with the central server using SIM300 module. LPC2148 kit has a 16:2 alphanumeric LCD to display the status of the bus, that is arrival timing and the vacancy. Stop 2 has similar architecture to Stop 1. Stop 2 uses MSP430F5438 development board as a controller. Here we have used two serial ports of this board. one of the serial port is connected to ZigBee module and another serial port is connected to SIM300 module. Now we need to have the voltage conversion between 3.3 volt and 5 volt because SIM300 works on 5 volt and MSP430 board works on 3.3 volt. In order to do the voltage conversion, we have developed a voltage conversion circuitry. The voltage conversion circuitry inside uses LM317 to generate the reference voltage of 3.3 volt and LM393 as a comparator to do the required conversion. So both the ICs LM393 and LM317 is provided by Texas Instruments. Central server is installed at the bus stand. It has the facility of graphical user interface. Central server is connected to SIM900 module so that it can communicate with the various bus stops and it can send the messages to various bus stops. A graphical user interface consists of a window to display incoming messages, a window to display the location of current bus, and a window to display the outgoing messages.
Now we will see the overall information flow of this project. This is the central server. Tickets have been already issued to the passengers by the conductor. When the bus comes near to the bus stop, current stop 1, the conductor will initiate the communication by giving the interrupt. Now the ticketing information has been forwarded to the bus stop through ZigBee and message has been already sent to the central server. You can see the message already sent to the central server on the GUI panel of the server. Server has sent the message to the next bus stop and that has been displayed on the LCD located at the next bus stop, stop 2.